I don't know about you, but development kits are some of my favorite things as an engineer. It's really cool to get some new technology all packaged up on a circuit board, apply some power, and see the thing come to life. Of course, usually come to life means some LEDs blink. Woo! Sometimes it can be rather, anticlimactic. Now, we're all engineers, so we know that behind the scenes, that blinking LED represents the hello world of some new fancy software-defined radio, some brushless motor controller, or our IoT-connected dog polisher. We can use our imaginations. But what happens when the thing we're building is a drone? I want a dev kit that can fly, baby. Hi, I'm Amelia Dalton, host of Chalk Talk. My guest today is Paul Guermonprez of Intel, and we're going to talk about some flying dev kits and Intel's drone development ecosystem. Okay, let's get started. But before we do get started, don't forget to click that link. There you can find out even more information about Intel's Aero autonomous drone platform. Okay, without further ado, let's go. Hi, Paul. Thank you so much for joining me today.
Thanks, hello.
So, as an engineer, I use a lot of different development kits, and usually a typical development kit will have a board with a processor and some kind of specialized hardware add-ons like a camera or screen interface. But today we're talking about a development kit that can fly, right?
Yes, so we have two products. One is the Intel Aero ready-to-fly drone. So this one comes already assembled, ready to fly, ready to code. And yes, you can fly with it. But we also have a set of ingredients that you can buy to integrate with your own drone. So that would be the compute board and the vision kit.
Okay, now there are a lot of drones around that people can pilot themselves with radio controls, but what we're really focused on here is developing autonomous drones for specific applications, correct?
Yes, exactly. So by default, the ready-to-fly drone comes with a radio remote, so you can fly it manually with a radio remote, no problem, but that's just for the beginning. Most people interested in this development kit would like the drone to fly autonomously and to code the behavior of the drone in their own software. And to do that, you would have to take advantage of a library to talk to the flight controller. You would probably like to work with the GPS, with the cameras, with a 3D sensor to scan the environment. So it's a totally different project than piloting a drone. This is an autonomous drone platform.
Right, okay. So what kind of applications are you seeing people use these kits to develop?
Yeah, definitely there's a lot of usage models that are real today where there is a real market for drone services. As an example, we have precision agriculture, so you could fly over a field autonomously, take high-resolution pictures of the field to detect the stress of the plants, or to drop some insect larvae, fight against some diseases, and that's really in production today. We also talk a lot about inspections for infrastructure like a bridge or a pipeline. You have a lot of logistics, if possible far from cities, because from a regulation point of view it's still difficult to fly in the cities. Inventory systems, for example, a large parking where you would want to run large inventories. Today we try to focus on usage models that are allowed by the regulation today, but there is definitely a lot of things that are possible.
Cool, okay. And before we get into all the fancy features of the development part and the development environment, let's dive into some specifics about the drone itself. What kind of performance does this ready-to-fly drone have?
Yeah, so by default, this drone is not designed for performance, it's designed as a development kit. So it's designed to be easy to repair, to extend, to modify, so it's not the ultimate performance drone. But we can still fly about 25 minutes hovering still with a regular battery. So it's a very honest flight time, and we can carry up to 850 grams, including the battery. So let's say you have a 200 or more grams battery, it leaves 500 grams for a payload, which is quite decent for a development platform.
Okay, great. Let's talk about payload. Is there some kind of I/O support that can connect up to my payload that will let me manage my payload as well as the flight of the drone?
Yeah, so we don't really provide specific payloads that are validated for Aero. We just provide a lot of IOs and documentation so you can plug your payload. So typically, a lot of clients would like to connect high resolution cameras. That would be a typical request. So we would recommend to go with the USB 3 port that we have on the Aero board. Such USB 3 cameras can be SLR, can be kind of Linux compatible cameras of a smaller shape. You have a lot of choice. And if you want a simpler sensor, you have all kinds of IOs available like CAN bus, SPI, I2C, serial of course. So it's very flexible. We try to make it as flexible as possible.
And some kinds of payloads, especially cameras, want a gimbal. Is there a gimbal as part of the drone, or is that something I would add on as a peripheral later on? How does that work?
Yeah, so it's not really part of the drone, but we offer IOs that allow you to connect your own gimbal. Usually a gimbal would be connected to one or two PWM channels. And yes, so you can do that. It's really a proof of how flexible the platform is.
Great, that gives me a really good feeling for the drone. Now, let's dive into some of the development part itself when we're customizing it. So, first, what kind of sensors and cameras and so forth are on this drone?
Yeah, so really the sensor is the interesting part of Aero because the compute board is great, it's Intel based, Atom, you have computing power like a processor, Atom processor, 2 gigs of memory, 32 gigs of flash storage, and you can extend that. But what is really fascinating about autonomous drone is all the sensors you can connect to this board. By default, when you buy the ready-to-fly drone, we provide Intel RealSense R200 camera, and this camera can scan in 3D what you have in front of the drone. That would be extremely useful if you want to do collision avoidance, which is a number one request you will have to solve when developing an autonomous drone solution. You can also scan the environment. An advanced usage model for this camera could be, for example, SLAM. It means mapping the environment around the drone. On top of this RealSense camera, we have a downward-facing camera that is black and white global shutter. And to summarize, we use this camera to look at the ground under the drone and to stabilize the drone visually compared to the ground. It's called optical flow. So we are releasing open source code to show you how to do that yourself.
Okay, and optical flow is for my altitude above ground or obstructions, correct?
Yeah, so the optical flow solution is maintaining altitude or height and also analyzing the patterns of the floor, let's say the carpet or grass, to stay exactly at the right position. Because let's say you are using the GPS that is included in the ready-to-fly drone. GPS is not really precise. You can have 3 meters or 10 feet of precision. It's not great. So without optical flow, the drone would move left and right. But with optical flow, you can hover very precisely within like a few inches by looking at the ground.
Got it. Okay, speaking of that, how does the navigation work and the autopilot and so forth? You mentioned GPS a couple of times, but what else is involved?
The architecture of the ready-to-fly drone is built with first a flight controller. So it's a very simple, classic microcontroller-based flight controller. It's called Intel Aero flight controller. And this is running an open source stack. So we use PX4, that's what we ship by default, but you can also flash RDPilot, which is also very popular. So you have the choice, it's totally open source. And this flight controller is connected to a GPS, so you can instruct the flight controller to fly to a specific position or to follow a specific path, to do these kind of things, and it will just execute that. You don't have to know all the details of how it is done. You can just give order, position, and it will execute. You communicate with the flight controller using the Mavlink protocol, which is very standard and open, well documented. All the IMU, the motion units, and all the sensors are included in the flight controller. So you don't have to worry about it. If you are a high-level software developer like me, you just give orders to the flight controller and it just works. On top of that, you can execute higher-level functions on the Linux side. Let's say write some code to receive orders from internet, from your IT system, or to analyze images and to process them and to decide you want to go to a GPS position. Then you would give the order of the GPS position to your flight controller. So that's the way it works. We use very simple localization technology like GPS for the flight controller, but you can use smarter, better systems like computer vision at the higher level on Linux.
Okay, so Paul, what kind of connectivity resources do we have on the drone for communicating with the ground and the outside world?
Yeah, so that's a very important point when you are developing an autonomous drone platform. When it's autonomous, you don't really want a radio control. We have one for development, but that's not what you want in production. It would be limited in range, and you can't afford to have one pilot for each drone of your fleet. Like if you have 10,000 drones, it wouldn't scale. So definitely having an IP-based connectivity to your data center is extremely important. And the great thing about Intel Aero is that we have a M.2 port, which is a professional port that can accept M.2 modems that are the professional kind of modems you would find on the market. So you could have a high bandwidth, high quality modem from Intel or other providers connected to this M.2 port, and you would have LTE connectivity thanks to this modem. Included in the development kit is the Wi-Fi part. So Aero can be accessed over Wi-Fi. That's great for development, for short-range development. You don't have to add anything. And later you know that you can move to LTE for long-range data connectivity.
Okay, so earlier you mentioned that there's an Atom processor, and you talked a little bit about that, but can you go into some more detail about the compute resources that are available on this drone?
Yeah, so we have a very interesting compute architecture with Intel Aero because we have at the center an Intel Atom processor running Linux, taking care of the modem, of all the PC-style connectivity you may want to use, like USB 3. And we have some dedicated chips that are doing very specific things very efficiently. So a typical small processor that you would have is inside the RealSense camera to process the binocular vision and to give you access to a 3D matrix of what is in front of the drone. That's a dedicated chip that is doing that for you. You don't have to worry about it. You don't have to deal with the software doing that. It's all done for you. You can also see the modem as a dedicated chip that is taking care of the LTE connection for you. And if you want, you also have a graphics chip on Intel Aero, part of the Atom system on chip, so you can offload some computations. Even more interesting, you can do neural network computing with an accessory called the Intel Movidius Neural Compute Stick. So that's a new kind of processing unit that is dedicated to a neural compute, and that's very interesting for computer vision. So let's say you want to detect some patterns when you do infrastructure inspection, or if you want to detect faces of people. Well, instead of doing that just with a big piece of software running on Intel Atom processor, you could offload that to a dedicated chip like the Movidius chip. So it's an option. It's not part of the Intel Aero drone by itself, but it's really interesting to know that you can access all this Intel ecosystem accessories from Intel Aero.
That's impressive. Now, let's shift gears and talk a little bit about the development environment for software and hardware. So, how do I develop and customize my application?
So when you buy the Intel Aero ready-to-fly drone, you have an Intel Aero board that is running Linux with Atom processor. You also have an Intel Aero flight controller that is a microcontroller-based system. So the flight controller, most high-level software developers like me don't really care about the flight controller, it just works. But it's good to know that it's an open source stack, so you can access it, you can flash it, you can modify it, you have total control over the lower level stack. It's a solid foundation. On Linux, that's what most developers would like to know. First, you have Linux Yocto that is shipped by default with the drone. Yocto is great because it's open source, it's very professional, so if you go in the aeronautics industry, they would definitely want to use Aero. Now, if you want to prototype Quickly, Aero Yocto may not be very useful, so you may want Ubuntu instead. So it's possible to flash the drone with Ubuntu later, after you receive it, and develop on Ubuntu. So that's for the OS level. On top of this OS, it's very simple. First, you have to understand that the communication with the flight controller is managed by a protocol called Mavlink. That is very standard. It is not Intel specific. A lot of flight controllers use this protocol. And to talk this protocol from Linux, you have a library, an open source library to do that. It's called libmavlink. On top of libmavlink, you have a choice of options. You can just write in C, C++ if you want something minimal. That's great. Some people do that. You can also use a higher level library like a drone core. That is a new library, open source also, that is getting some popularity right now. If you are more in the robotics world and you want something very elaborate and very flexible, very portable, that would not be only for drones, you may want to consider Robotic Operating System or ROS. We support ROS. We ship it installed by default on the drone. You don't have to use it, but it's definitely interesting to evaluate, to know how it works, because a lot of the robots of the future will use ROS or a variant of ROS. And from this Linux platform or ROS on top of Linux, you can access all the non-drone specific libraries like computer vision, access to the cloud, pattern recognition, neural networks. A lot of things are available on a typical Linux platform.
Wow, that's a lot of support resources. So, when I'm ready to get started, what kind of documentation is available and where can I go for more details for this development?
Yeah, so you have the intel.com/aero website. That is the main first website. But if you're an engineer and you're thinking about the documentation and the SDK and all the details, you may want to go to our GitHub page. So just look for Intel Aero and you will find our GitHub page. And from this GitHub, you have all the documentation that is updated like every week. You also have a full course that is open source that professors could use to build their own course if you want to teach drone development. As an engineer, you can also use this course to train yourself. It's totally available. So you have some slides, some PDFs, some YouTube videos, and we try to update it on a regular basis. So that would be my first advice. Go to the GitHub page. And when you receive your hardware, make sure you flash all your components, the Linux board, the flight controller, everything as described on the GitHub page to make sure you have the latest on firmware.
Okay, fantastic. I'm going to click on this link right now and order my kit from Mouser. But once I get my kit, what are the first steps that I need to do to get it started?
Yeah, so two cases. First, if you receive the Intel Aero ready-to-fly drone, there is everything you need except the battery. So you can go to a local shop. It's a very standard battery connector. We have all the specification on the GitHub page. Very simple. You don't have to have an Intel specific battery. It's all very standard. On a battery charger, also very standard. To flash the drone with the latest software, which is really the first thing you should do, you will need a micro HDMI cable and also USB OTG adapter. So you may have already that at home. If not, you may buy that with the drone. Now, if you buy the board itself without the drone and you want to do development on your desk, what you may want to have is a power supply. So also the specification are on the GitHub page. It's a very standard 12-volt battery supply. Just pick the right capabilities for the power supply, but it's very standard. And same thing for the cables. That way you will be able to flash, then access as root the board and get started developing your own thing.
Okay, so one more thing to clarify before we go. If I develop my drone application using this drone and this kit, I then have the ability to move to a different flying platform if there's one that has more specific range or payload or whatever my application requires, right?
Yeah, so it's important to understand that we have a full drone strategy at Intel. So what you see here is the prototyping platform. It's very open. It's designed to explore new possibilities. So you can be a R&D department in a big company. You can be a researcher or professor, or just you like to develop software on the weekends. But yeah, it's for exploration. It's good to know that you can go to production. Because even if the ready-to-fly drone is not designed for production itself, it's a bit small, it has some limitations, it's very flexible, but it has some limitations, you can definitely buy the board and put it on a production drone later. All you need to have is a serial port to connect to your flight controller and the right power connectivity for the board to function. But that's very simple, it's well documented. So we are not trying to lock you with a specific drone that we are selling. What we are selling is just a starting point to go further. So we have some partners that can help you build your drone if you don't want to deal with the mechanics of building the drone. It's definitely a job. It's interesting to know also that if you want to take advantage of our professional drone offering, you can later move to the professional line of drones that we have at Intel, for example, Intel Falcon 8 Plus.
Got it. Okay, I am excited to start on my drone project. Thank you, Paul. Thank you so much for joining me today.
Thanks, it was a pleasure.
And before we go, you didn't forget to click that link, did you? There you can find out even more information about Intel's Aero autonomous drone platform. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of eejournal.com or simply head on over to YouTube, keyword EE Journal.